So perfect. So today's topic is around threat detection and how to really monitor cloud data for a variety of anomalies that we'll kind of walk through as a couple examples within the demo environment. And today's session, we'll have a little bit more focus around the cloud security monitoring and analytics piece of the security solutions puzzle, as well as Cloud SIEM. We'll talk about kind of from a prioritization investigation and where detection kind of slots into that, as well as Cloud SOAR as we consider kind of the orchestration, automation of the response once the detection investigation had kind of been run through. So there are a couple ways in which Sumo really helps to improve security posture with security analytics and really help to especially accelerate how you can perform better detection. So because we're able to pull in any number of cloud native data sources, which will kind of give a couple of categorized uh, sort of visualizations of what that looks like on the slide in a second. That really allows for very much increased visibility and being able to really be able to secure and monitor and analyze a whole host of cloud as well as on-premise data sources. And then because the analytics themselves are very focused around the security analytics use case, really allows for analytics capabilities to be designed specifically for security engineering teams to prioritize those detections that come into the system, as well as investigate and respond to active security incidents. And we'll kind of focus a little bit more around the detection piece as the core kind of use case for today's session. As you think about the general flow of how a security engineer or security analyst would utilize our platform, it's really going to always start with collection, right? Because that's what allows you to really bring in this variety of data sources initially that you know that you want to have a close eye on and have the ability to detect. And then the analysis, which really is where you can tune the various queries that underpin all the dashboards to allow you to determine what you're detecting, how you're detecting it, kind of what level of granularity that analysis is getting into by way of the parsing, format, merge, time slice operators, etc. And then alerts, which can be saved down from the analysis. And we'll show an example of that in the demo, and then visualization, which is the actual dashboarding itself, and the kind of ongoing detection of potential security concerns that we'll get into in the demo. So as I mentioned, the way that we think about how the data sources are really broken out, it's really inclusive of apps, so external products with external authentication for your customers that you're building. So obviously a little different set of security concerns around how you think about customer data versus internal corporate IT data, such as Zoom, Slack, etc. Multi-cloud would be inclusive of all cloud infrastructure here, so really AWS, Azure, GCP, etc., as well as on-premise data. So we have for sure a whole host of customers that really think about how do we better monitor, whether it's local device data such as a MacBook or iPhone, as well as the ability to really monitor data center systems as well, and really have a close eye on those. Once you're able to ingest those in, then you can really perform security monitoring and security analytics. And we'll talk about in the demo what there's kind of an overview perspective that you can achieve with the monitoring through dashboards. And then you can go deeper and really tune to your use case for security analytics. And you're then able to then monitor and analyze and kind of pivot out at the granularity of devices, IPs, networks, databases, etc. So this is the cloud security monitoring and analytics platform, which really focuses around enabling, like I said, the detection, the processing of those detections. Investigation response can also occur here, although that starts to get into more of a Cloud SIEM or Cloud SOAR use case, which will be covered in future sessions within our webinars. And you're really able to analyze at the user level. So we'll look at what it looks like to actually set those filters and those template variables to have the better sense from that, what that looks like. When we talk about prioritizing threats, what we really mean is there are any number of detected possible, insights that need to be responded to or be made aware of. But it's also really critical to be able to prioritize those detections really early on. So once you bring in all of this on-prem and cloud data, and really want to better understand what it looks like to surface just the most relevant insights, that's how you can really tune kind of the out-of-the-box content to align back with what your particular highest concern or highest 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 concern of data access or data privilege or data or I should say privileged access, to combine the two. Or it could be that there's just a lot of raw data, raw message event level data that you want to really have a close eye on, and then be able to actually bubble that up via whether it's the log reduce operator to then be able to really summarize what you're seeing and kind of club together all of the queries. Or you can have that really granular data and stay in the weeds with that, just depending on whether it's kind of a situation where you already kind of know what the needle in the haystack is or not. So now I'm going to jump ahead to kind of the investigation piece. So once you have that awareness of detection and you have just enough data flowing in the system to where you already kind of know where the outliers are occurring, then you can kind of perform those deeper investigations and really get down to the security analytics level and say, how do I tune this query to really align back with what my needs are for my team? And here you can see, for example, it's count by event and time slice, transpose row time slice, but we're actually time slicing down to the 1 hour here. So in this case, for example, maybe it's better to go more granular, or you want to get a bigger generalization and actually go all the way up to, as long as makes sense to tune the query based on around these requirements. So it could be that you only need to know at the 24-hour mark because you're actually looking at a broad swath of data over months or even years in some cases. So with that, I'm going to jump into the demo. And as I mentioned, today's demo is more focused around cloud security monitoring and analytics, or the continuous intelligence platform that we'll look at today. But there are a lot of ways in which the detection aspect really keys in on where Cloud SIEM and Cloud SOAR can really come into play and be really helpful for this particular set of scenarios. So for today, I'll really focus around Linux data in particular. So I'm just going to open up a couple of what I think will be relevant dashboards that we can kind of run through. And these are all available out of the box within their app catalog. So if you go to the security section of our app catalog, you can actually find all of the cloud security monitoring and analytics apps that we've added in, including 1Password, CloudTrail, GuardDuty, VPC Flow, Linux. So we'll focus on Linux for today for kind of more of a, I would call it more of a vanilla operating system kind of level of approach of how we can kind of use a more canonical example, just to be a little bit less or a little bit more vendor agnostic for today. But absolutely, we could, and feel free, I should mention, ask questions all throughout in the Q&A, chat, etc. But if you'd like, you could absolutely, we could go deeper on Amazon or go deeper on any of these more kind of vendor specific examples. But here today, I'll focus on Linux. So with Linux security monitoring, with the actual overview here, you can see kind of a broad-based look at a potential detection, although in this case, we're not seeing anything jumping out at us because the spark lines are very flat, as you can see. But we have we have the failed logins, which are very, so 901 failures versus 3,964 logins is kind of a typical ratio to what I see, but it is on the high side in a general sense. I mean, it's typical what I see for this demo, but in a typical, production environment, we'd probably expect to see a lower number of failed logins than kind of this 1-to-4 ratio. I think that's indicating right to us that, and we could absolutely add a panel if it were of relevance for a team. We could add a panel here just that shows the ratio even, but we can see that it's roughly 20% of overall, which is failed logins. So we'll kind of go a little bit deeper on that and see if that's an anomaly or kind of if that aligns with our typical timeline or in corporate IT expectations within this environment. But then if I go a bit deeper into, now we're going down to the kind of security analytics level and going a little bit deeper, and we're actually going to have the ability to pivot out at the user service or system monitoring level. We're looking here at user account modifications, and we see the number of services, 63 that are currently running within this environment. And we see some that are as we'd expect it to be. We do see some common services. So we see SSHD, DH client, daemon, etc. But then as we kind of go deeper and get into the less common, we should confirm, for example, with our team that we know for sure Unix check passwords should be running here. and that that's an expected behavior, and that that's not kind of a bad actor that's utilizing that service in some kind of anomalous way. Or we might want to dig into, for example, Greeter, if that's a service that we are actively using, or if that's something that's actively been moved away from and moved towards, and what kind of the trend lines are that we expect to see in terms of the running services over time. So as you can see, and it'll probably be a little bit more relevant in the next dashboard that we jump into, but as you can see here, we can also pivot out by destination host. So maybe I just want to look at a particular destination host. So in this case, we're looking at Rishi Time Machine, and we're seeing for this host alone, we see some commonalities, right? So it's still SSHD. We actually see about 20 fewer services running for this particular user or for this host. And so as we kind of dig deeper, we can better understand and say, okay, this is kind of as how I expect this alignment to take place, and how I expect the behavior to change based on a set of users. And again, sometimes you go in with advanced knowledge, so you already have detection awareness that you want to key in on a particular destination host, in which case you can actually make that proactive decision to kind of set that filter accordingly and really kind of align back based on that. So next up, I'm going to run through Linux security analytics for privileged activity. So I think this is where it gets interesting, right? Because I think you're speaking of needle in the haystack and kind of where we sit in the kind of the detection pipeline, if we can call it that. We're actually kind of considering here, well, we already know that the privileged activity is for a set of particularly, higher concern resources that we do want to consider and better understand what is occurring within them. So we see the sudo attempt outlier. We're less concerned with the low. So all the pink triangles indicate it's falling outside of the expected range for the way this query is built. We're probably a little bit less concerned with the low end of these outliers, because that's simply telling us that there are a low number of sudo attempts within a given time period. But you can imagine we would be concerned if we see these high spikes that are occurring, because that's telling us that potentially this could be a brute force attack, right? Where we have maybe in some cases 500 count attempts, which is certainly on the high side for this particular environment, at the 9:45 or the 10-hour mark. 10:30 hour mark, in that range. So over 1 hour, we're seeing several thousands of attempts, and that would indicate to us that there may be, like I said, a brute force attack, and we may want to dig in on that. So let's look at a couple things around that. So firstly, this is the actual log search or query that underpins the security analytics that achieves this. So a couple things of note. So we see that we're looking at essentially all Linux data, because this star is indicating to us that we're wildcarding on the all Linux data that at least that comes after this labs OS collector. And then sudo is set as a keyword. So we're only looking at sudo attempts here. And we're saying every time we say we're source user matches, destination user matches, etc., then we can, this star actually, as opposed to a wildcard, is indicating that this is actually a template variable that we can then keep as a variable and as a filter that we can determine later. And as we discussed earlier in the demo, we could certainly open up this time slice to a wider period. I would probably argue that 15 minutes is a little too granular, right? Because we're looking at it so in such a kind of micro level that this may indicate to us that it's only falling outside the expected range for a very finite amount of time. So it actually might be more valuable to open up the whole chart to a broader view, but also open up the time slice so that we're kind of getting broader generalizations. So yeah, so as I mentioned, all these pink triangles indicate we're falling outside the range. We can then save this down, schedule the search as let's say real time, I think is always most relevant. Although in some cases you're getting too many alerts and you actually want to tune that, but just I think it's interesting to look at this scenario. We can send this out to like an email distribution or webhook. So it could go out to Slack or Microsoft Teams, and then you could actually perform, I mean, we're more focused around detection today, but you could go all the way down to response here and perform a quarantining of hosts from within your Slack or Microsoft Teams environment by responding to that alert within it. So you have the ability to really have this more ad hoc approach that I think can be valuable as you kind of deal with unexpected situations, right? I think SOAR, for example, is going to be perfect for when you want to orchestrate a common set of use cases that your team sees all the time. But in the case of other scenarios, you might be a little bit more one-off. It might be a situation where you didn't expect to see some ad hoc event, and so you want to actually build around that and determine accordingly. And then we see pseudo failures over time. So as you can see, this is a far lower ratio than our security monitoring example at the top. There are only 263 failures versus 41,000 attempts. So because it's pseudo, that makes sense, right? There are fewer people that have access to this, but also there may be cron jobs that are running access, early access points to pseudo attempts that are determining or that are causing there to be so many successful attempts, because it may be that it's more of an automated job that's making that happen. So I'll close out today's demo with a little different lens in the login activity. So here we're looking at all user login attempts. So again, we're kind of backing out away from pseudo, and we're saying, what does this look like in the broader sense? We see a huge number of logins, but based on the ratios, the failed logins may be kind of an acceptable number. And then here we actually see, we see one pink triangle at the high end over 24 hours. So we may want to better understand just this particular occurrence. And we can actually, I clicked on the pink triangle so that we can actually look at the all logs, error signatures, the various entities, in this case, that are not assigned, but that you can see that are associated just at the raw message level. And then we also have the ability to key in on, just like some of the other examples we looked at, if we only wanted to look at root destination host, or if we wanted to look at source host. In this case, we could look at like Duke's MacBook Pro, I believe is in here. So then we could, again, just start to set some of those filters, and we can pivot out at the IP level, for example. And this is cases where you already know that there's a potential, maybe not even bad actor, but just that maybe someone is attempting to access a good actor with bad means, and then you know that that's the kind of the potential, let's say, attack vector that's being utilized, and then you want to better understand through that. So that pretty well covers today's demo. So this is, again, to primarily focus around cloud security monitoring, but certainly detection comes into play within the scope and context of Cloud SIEM and Cloud SOAR as well. And these are a couple of resources. I'll pop these into the chat in case you'd like to dig into any of these and go a little bit deeper. Those are a couple of resources. You also have the ability to sign up for a free trial if you wanted to sort of get up and running. And you could even just use dummy data, or you could use production data if you want to kind of dive in from there. Reach out to sales@sumologic.com if you do kind of want to dive straight into more of the conversation side of the picture. And again, today's session was focused around threat detection and being able to monitor primarily cloud data for anomalies. My name is Jason Dunn. I'm a product marketing manager here at Sumo Logic. And I'll just kind of go on mute here for a moment. If you do have questions, that they come to you in the next couple minutes, I'll stay on the line for a few more minutes and we can kind of take it from there. But thanks so much for joining today's session. And we will also make this recording available if you'd like to share it with your teammates as well. Thank you so much.